Hello. I hope that the test went well for everyone. We are going to actually start chapter 9 before spring break. So, up to this point, we have been concerned primarily with pure substances, both elements and compounds in day-to-day life. However, most of the materials we come in contact with are mixtures. Air, for example, is a gaseous mixture of primarily oxygen and nitrogen. Blood is a liquid mixture of many different components, and many rocks are solid mixtures of different materials. In this chapter, we look closely at the characteristics and properties of mixtures with particles, attention to the uniform mixtures we call solutions. So we are going to start chapter 9.1, which is going to be mixtures and solutions. This is going to be on page 255. So the first thing that we are going to do is we are going to define heterogeneous mixture, which is a non-uniform mixture that has regions of different composition. So we also need to know figure 9.1 on page 255. And this is going to be classifications of mixtures, which is the components in heterogeneous mixtures are not uniformly mixed, and the composition varies with location. In homogeneous mixtures, the components are uniformly mixed at the molecular level. So how we determine this is we're going to use this chart. So matter is going to be at the top. We're going to ask ourselves, are properties and composition constant? There's going to be two answers. There's going to be no, and there's going to be yes. If it's yes, it's going to be a pure substance. If it's no, it's going to be a mixture, which examples of these are seawater, mayo, and rocks. And here, this is physical change. So physical change can occur to this to make it a pure substance, and it can go back and forth. So a mixture, therefore, can then be moved to two things. A mixture can be heterogeneous and homogeneous. And homogeneous mixtures can be solutions or colloids. So now we're going to define all of these things in this chart. So the next definition that we are going to go over is homogeneous. Mixture, which is a uniform mixture that has the same composition throughout. The next definition is a definition of a solution, which is a homogeneous mixture that contains particles the size of a typical ion or small molecule. So then a colloid is also a homogeneous mixture that contains particles that range in diameter from 2 to 500 nanometers. So if you look at this example in your book here, there's A, B, and C. A is wine. Wine is a solution of dissolved molecules. B is milk. Milk is a colloid with fine particles that do not separate on standing. C is an aerosol spray. By contrast, is a heterogeneous mixture of small particles visible within the naked eye. So these are examples of each, which you guys need to know as well. So then we are also going to go over table 9.1, which is going to be characteristics. So we're going to go, there's going to be solution, fluid, and heterogeneous. So the size of these particles, these solutions are less than 2.0 nanometers. These are between 2 and 500 nanometers, and this is greater than 500 nanometers. So an example for these are going to be air, seawater, gas, wine. Example of this is going to be mutter, milk, fog, pearl. An example of this is going to be blood, paint, aerosol. And then the characteristics are going to be transparent, does not separate. So like for example, if you were to leave orange juice in the refrigerator, it would separate once you left it standing. So if it doesn't separate with standing, that would be something like obviously the air. The air doesn't separate into separate particles, it's always mixed. And this is non-filterable. So this is colloids are often murky, like milk. Does not separate. And non-filterable. So then this is murky, and this separates, and it's filterable. So that's like, for example, you can donate your plasma for your blood. So therefore they spin your blood and they take out the plasma and can put your blood back inside of you. So therefore it's filterable. So with this chart, what I hope that you can get from it is if I were to give you an example of something, you could use this chart and know this chart and be able to determine if it's a solution of colloid or heterogeneous by what it is. So next thing we're going to do is we are going to define solute, which is a substance dissolved in a liquid. So for example, in salt water, the solute would be salt. The solvent is the liquid in which another substance is dissolved. So if we had salt, water, the solute would be salt, the solvent would be water. I don't know why I put E there. So you also need to know table 9.2, which is some different types of solutions. So if we have type over here, we're going to have gas in gas, gas in liquid, gas in solid, liquid in liquid, liquid in solid, solid in liquid, solid in solid. So you're going to need to know the examples for each of these. So a gas and gas would be air. This is going to be a gas and liquid would be seltzer water. Gas is going to be hydrogen in palladium metal. Liquid and liquid is going to be gas. Liquid and solid is going to be dental amalgam. Solid and liquid is going to be seawater. Solid and solid is going to be metal alloys, such as 14 karat gold. And for homework, you are going to do problem 9.1 on page 257. That'll be your homework before spring break. I'll attach the link below too as well so you can turn it in so you don't forget about it until after break. I hope that you have a great spring break. Stay safe. Get some fresh air as needed, please.